Okay, hope you like that little video to sort of give us an intro. Don't forget, sort of during the whole webinar, sort of please ask questions. It's been moderated by our sort of digital lead, Alex. So he'll sort of keep an eye on that, and I'll try and answer questions as we go along. But it's, yeah, if we can be as interactive as we can, I'll try and answer questions. I've got a gentleman here called Paul Simpson, who is going to be sort of joining us as the assembly manager. Paul's going to sort of do a demonstration as we sort of go along, and I might jump in once in a while. But yeah, feel free to ask questions. I can see them on the side. Okay, quick webinar. Here's a few slides for you. Yeah, as we sort of say, you can't reinvent the wheel, but you can reinvent the wall. Interesting fact about concrete. It's the third highest emitter of CO2 behind the USA and China if it was a country, which I find quite staggering, if I'm being honest. So concrete's a problem. Plastic, as we all know, is a problem. Doesn't need me to go over the issues. We all know what they are. We produce too much of it because what we do is we make the most throwaway items out of the most permanent materials. So, what's the problem? Plastic waste, housing's a problem, flooding's a problem. We think we've got a solution that solves all three in one. Our initial sort of market, we've identified we can do buildings, we've identified we can do flood defences, we've identified we can do a variety of things, but we sort of do believe that our initial market should be things such as, there we go, what we call task pods or garden pods, home-based buildings, structures. At the minute, these things are made out of wood, like log cabins, SIPs, porta cabins, this sort of thing. And it's a huge market. I mean, in the UK alone, £110 million was spent in 2012, but in 2022, it's estimated to be 650 million because people are naturally sort of staying at home a lot more. People sort of are enjoying the home a lot more. But equally, sort of, we recognise the fact that people want to work from home. And with the pandemic that's just taken place, you know, sort of 33% of all employees will work remotely at some point, and 53% of those will hybrid work. So that potentially is a huge market for a garden officers. We think it's a massive market, not just in the UK, but you know, sort of certainly in Europe and certainly in North America. And that really is our initial market. Things such as what we call our task pods, that's one of our garden rooms, that's another one of our garden rooms. And we make these what we call task pods, which are quite small, can be sort of shed type buildings of studio sized, bigger, smaller, according to the customer or the client's need. That's going to be our focus. But we do recognise that we can use our system for a variety of things: homeless shelters, flood defences, dividing systems such as exhibition stands, that sort of thing, and also pop-up buildings such as medipods, incident pods for police, those sort of markets, all from the same system, all using the same technology, just a matter of how you build it, basically. Right. So don't take our word for it. We'll show you how we do it live. Hold on, I'll just turn that off. Okay, as you can sort of see on the camera here, we have a small building. I mean, so obviously with the time constraints, we couldn't build a huge building, but we can show all the component parts of what we do using a small little sort of foundation that we'll build a sort of a two core structure, which will sort of show all component parts of how we build. I'll just put my camera on for the moment very quickly. What I will sort of show you before we sort of start is, you can see the black thing on the floor, that's foundation. What we do is, this is one of our key pieces, as you can sort of see here. We have, in our extrusion, we have predefined grooves for the brackets, so that you can't, as long as that piece has been cut correctly, you can't put the bracket in incorrectly. It's if you like a foolproof system. Well, we'll soon find out if Paul builds it correctly. Okay, I'm going to sort of turn the camera off for a moment and let Paul do his thing. And what Paul's going to do is he's going to build the first course. As you sort of see on here, there's a foundation. We've got some green pieces there, which we call the spars, which are the cross members. As you can see on there. And what we do is, you'll see around the edge, there's a small little lip that allows us to put the floorboards in. Keeping the theme of what we do, we're using recycled styrene for the floorboards. And then what we then do is simply, if we want to put a screw into that screws that floor into the cross members to sort of stop the floor bounce. If that sort of makes sense, I'll just put my camera back on again for a moment. Right, okay, so I've explained how the foundation works. What I should mention is, if we want to level that foundation up, we can use effectively sort of pieces of self-leveling feet, because of course, sort of depending on what ground it goes on, it's not going to be the most level of surfaces. So what we do is we pre-drill our foundation piece and have these simple feet, rubberized feet that we can adjust from the top to level the building across to what we want. That makes sense. Okay. So Paul is now going to put on the first course. As you sort of see, he's putting the outer in first. Levels it across. It's all pre-cut in the factory, of course. One screw. Goes in. Holds it in place. Check the corners are straight. Yeah, check the corners are straight, which is yeah. And what Paul's now going to do is going to put a bracket in the corner. Once again, on the brown piece, there's also grooves very similar to the foundation that ensure that the bracket goes in exactly as it should do for the corner. Then you can put you can see there, just adjusting that. With the bracket in place, which, like I say, as long as it's being cut correctly in the factory, or cut correctly, is a mighty corner. And depending on what we're doing, we can put either two brackets in there or a single bracket. We have actually built most of our buildings with single brackets on the inside. Two brackets, it doesn't really need it overall. We've sort of found from our experience. Yeah, you see, put the bracket in a different position this time. I think, can't really see me. Yeah. Just see if we can. As long as it gets the screw in place. No pressure, Paul. What I should sort of say, which I'm not sure if you sort of saw from the start there, Paul's picking the pieces from behind you. Because of the way that the system packs away, it actually packs away to 1/5 of its build size. Like I say, so what we've worked out is that we can actually fit enough material into a 40-foot container to build a 6.5 feet wall around the football pitch. That's how compact the taxi is. Yeah, I mean, obviously our names are play on the word Lego, but really it's more like IKEA because it's flat pack as opposed to Lego, which is what we do is we don't add air to our product. We add air on site. Now what you see now is what Paul is doing. He is putting the inner piece of the wall in, which once again has been cut such that it's a convex system there. It's the inverse of the wall, and what he's doing is putting each piece in again. Like that. The bracket place there. And on this piece, you'll notice there's one bracket which is a centralised bracket on the top. It's done that way so that the bracket on the top doesn't interfere with the brackets underneath it effectively. If it was on a foundation piece. I'll try and answer some questions as we go along here. Henry, are you planning to sell these raw to or as modular packs? It'll have to be a modular pack, really, Henry. That's the plan. Louise, what's your plan to tackle homelessness? Will you take this product to government? Yes, we will. Obviously, we want to prove the product in the market before we go through layers of government, which can be quite onerous. Yeah, Louise looks really easy to assemble. Does it use standard screws? Yes, basically, what we've done is we've designed a system such that apart from the OGEL parts, everything can be bought in screw fix. That's the idea. But obviously, we would supply it with screws, brackets, and everything. But the idea is that if you run out of screws or run out of brackets, you can buy them screw fix. It's a standard screw fix part. Aaron would like to hear more about this as well. I don't know what that means. Okay, yes, about buying from the hardware store. Yeah, okay. So we've now put one course on. As you'll appreciate, this is only a small building, but the size to a certain degree is irrelevant. It's to show the purpose of how it works. I'm going to just quickly put that back into my camera for a moment because I want to show you a couple of features. Bear with me for a moment. Okay. Right. I've done a little cutaway to show you something about the system, how we designed the system. As I mentioned before, you can see on the side of the black here, there's a little groove, this little ledge. And the wood system is designed such that the floorboards, when they go in, actually go underneath the wall. So it provides an absolutely secure fitting. And what we can then do is, that is pretty much waterproof as it is, but obviously if we put a silicon bead along there, that makes that floor completely waterproof, which I think is one of my favourite little design quirks. Okay. I think Paul's going to put the second course on now. So same principle again. Just leave him to now, probably 5 minutes. I mentioned before, the secret's on the bracket, as long as the building's been put correctly, the brackets will pull everything too. Down, Paul, you know. Go back to a couple of questions here. Is the plan to get the government to provide flood defences to high-flooding areas? Flooding is an interesting sort of subject. Flooding is actually covered by the Environment Agency, so we have spoken to them very initially about what we want to do. We are sort of talking to a number of people sort of about it really. It's quite a complex thing, flood defences. So what we're doing initially is leaving that till probably midway through next year and then begin conversations with the Environment Agency, in essence. Richard, do you put insulation in the cavity? You can do, but you actually don't need it, would you believe? Because the U value, because it's styrene, because the air is effectively trapped in the wall, it gives it a U value of 0.117, which is about the equivalent of a double skin brick wall with insulation in the middle. So it doesn't actually need it. Will the garden office be okay with very strong winds? Yes, because what we do is, obviously we can't show it on here, but we actually screw that foundation, or screw the spars into the ground, so it can't lift up. But it isn't actually super light. It isn't like flaky polystyrene. Noise impact from heavy rain. You don't hear it because it's double skinned. To answer that question, Sharita. Henry, so the aim for garden rooms will be whole building to turn upon pallets like a giant project. Yes. The question on the base requirements, which is a good question. What we can do is, and we've already tested to do so, we don't need a concrete base. We can build these onto what's called ground screws, which are, as the name sort of suggests, like large screw type devices that you hand screw into the floor, and then effectively sort of screw the base onto that, so it can actually just go into normal ground, and then we sort of level off the ground screws. Is there a market to take this for army uses? Yes, we believe there is. Once again, as you'd appreciate, it's quite a long procurement process, which is part of the reason why we've built garden rooms and garden offices to begin with. But the same garden room will just have military decals on it and be used for the army, if they're interested in building in it, you know. But yes, we view the whole flat pack, disaster relief, army use as being one of our markets. Paul's can now put the second level on. What we're now going to do is just show a few of the finishing parts. I'm going to just build in one corner, and I'll explain why we're doing that in a moment. Phil, is it stronger than standard UPVC? Yes, it is, definitely. We have had this tested by the University of Coventry, Its compressive strength is 5.4 tons, which is about the same as thermalite block. It's actually very, even though it's a hollow system, it's very, very strong. So yes, a lot stronger than standard UPVC, a lot stronger. Fire rating, we don't have a fire rating at the moment. We have done some basic tests. It doesn't have, for garden rooms, it doesn't need a fire rating, but what we do is we treat it with an incandescent coating, which gives us about 35 minutes. But if you wanted to make that such that it was okay for full household use to live in, all we would do is we'd simply put a gypsum board on the inside to give it a 1 hour rating. That answers your question, Richard, hopefully. So Paul's put a little corner on there now, and the reason why I put that corner on is to replicate effectively a window. So what we do here is, I think you'll need some nubbins in there, Paul. Yeah. Aha. What Paul's now going to put in is what we call noggins. You see these two bits here? Yeah. Is it worth doing on the side one, Paul? Yeah. What these noggin pieces do is, slides in. What these actually work for is to provide a locking piece for our capping and extrusion, and also a place so that we can tie windows to it, to the wall, which you'll see in a moment. If we've only got the one screw, we'll just use yeah. Okay, so I see the little noggins on there now. Okay, now what Paul's now going to do is put some capping pieces on. And the same as you would for a window or a door. I haven't got a window or door to sort of prove that it works, but believe me, it does. And what he's now going to do is he's going to tie these, what we call C-caps, effectively, sort of, which then gives something for, obviously, sort of for the window to sit on. Or door. Does it come with a 45? Right? All parts come with 45 degrees. Yeah, and you'll come with 45, so it's all neat and tidy. Okay. Right. That's worth turning around a little bit to sort of show people. Yeah, cool. You can see it on there. Yeah, all nice and smooth. Right, that explains how the basic system works. A window will go on here, tie in, you tie the window to noggins, which obviously cover these screws. You put your window, your door in, exactly the same principle. Right, how do we do a roof? Our roof is exactly the same principle. All we do is we simply turn our pieces sideways on. So we have to imagine now that we've built up 7 or 8 course high. We're now putting the roof on. Yeah, so it's measured to, well, that's one, you normally have an overhang over a door area. For example, We've got the questions. Thanks, Louise. Yes, we're trying to sort of. Can somebody devise a way of assembling? Can somebody devise a way of segmenting our IP? Well, always possible, but unlikely unless they can invent a different way of doing an L shape. A key feature on our system, which I can't really sort of show you on this system, it's quite small, is the fact that if we want to build a long wall, we actually overlap the back and the front, so that wherever we have joints, the joints overlap each other, and that's a key component of our design. So theoretically, if somebody wanted to make something of 2 meters long, they could possibly could they beat our patent? Unlikely, because of some of the features we have involved in it. But certainly, if they want to build anything above 2 meters long, they would struggle a little bit. Can I paint outside? Yes, you can. You can paint it. You can decal it. You can clad it exactly the same as you would everything else. Mike, where will the electric sockets be installed? Stay with me on this one. I'll show you how that works in a minute, because I've got another piece I can show you. And I should see there, Paul's now put the first piece on, and then what he would do is, if he was building a whole wall, he would then join that piece, next piece, next piece. He's going to put a noggin in there, and then what he would then do is, which we haven't got any here, is we would put what's called a damp-proof membrane on that roof, which is a thin tarpaulin, but it's designed to have a 25-year guarantee. He would put that on, and then what he would do is the same C cap that he used for the windows. He would do the same thing around the outside of the building, for the outside of the roof, for the to cap the roof in the same way he capped the piece for the window and the door, or window stroke door. You can see there, put some pieces together. And then all three cut. Put that in there like that. Obviously, you put a screw through there, and that would retain the damp-proof membrane on the roof, and also make the whole job neat, if you like. And that is the basic system of how it works. To go back to a couple of questions, which I'm sure you have, which I'm trying to sort of cover as we go along. One question was about the about painting it and decaling it. As you can appreciate, the wall is actually very, very smooth. Okay, so if they want to put a decal on that, you can put it on straight away. You can wallpaper it. You can do whatever you want with it. It's effectively, yes, it's got a small line. But the line is so, it's a bit like Lego. It's fairly noticeable. So once you put a any sort of coating on it or cladding on it, you're not going to notice that line. Which, if anybody's seen our video, so we have a building that's been fully clad, and you can if you go right close, you can see the joints, but otherwise you can't. It's looking to take that roof off there, Paul. I'll show people how the electrics work. Actually, I tell you what I'll use it. If you don't mind, I'll go back to the normal camera. If you bear with me a moment. Yeah, people asked about electrics. Yeah, we standard electrics. What we do is, see there, we actually see there. We actually do the electrics are pre-routed, a pre-routed piece, and we actually do the electrics as we build the building, because we run the cables at the same time, which most standard building you would. The builder would come in and do his bit, then the electrician would come in and do his first fix, then the plasterer would come along, and then the electrician would come back and do his second fix, whereas we do the whole thing at once, at the same time. Just because we know the length of the cables, we use what's called Wagos to attach the system together internally for the wiring. So that's how we do electrics. Thank you, as I appreciate to be able to. I now need to leave. Oh yeah. Thanks, Stuart. Okay, you've got to leave. No problem. Richard, is there no pitch on the roof? Depending on the size of the building, we are working on a pitch system, but at the minute, for this size of roof, we don't actually need it, because what we do is we actually design the building, we put a slight pitch on the building, so the water runs off the back, and we have drainage at the back. But we are looking at one of the developments next year, developing a pitch system. Okay, Alicia, how does the temperature cope with this material, such as retaining heat in summer? It's fantastic. It's very, very good. We've had a building out, fully built. Once again, because the U value is so high, it works the same way. So it's very cool in the summer, very warm in the winter. Put a bit of heating on, and it retains it, very, very well. Any more questions on the system? Cover. Oh yes, one of the questions which I did want to cover is this piece here. Or we don't a thinner piece. That's for the corners. We cut the corner pieces over like that. You can see that in there. Obviously in a white colour. I'm developing a thinner version for the cladding, so that's less obvious. And the thinner version is also supposed to be inside of the wall as well, just for neatness. Or you can use a silicon bead on the inside. Anything else? Other developments as we go along, which are worth mentioning, is we know we can build 2 stories, and I'll tell you how we do it. This is our beams, which is also this polystyrene, but extremely strong. Can take a lot of weight. What we do is, imagine this is our wall. It's the top of our wall. What we do is we actually cut in a shape on the inside wall, and we feed in our beam like that and attach that using the brackets here, using little L brackets that attach. I'll show one. Pre-cut joist feeds in like that, as you can see, and we attach it the joist internal of the wall like that, with one of those little brackets. Okay, so it's cut on the inside, but you can't see it on the outside. So that's how we build 2-story. Next question: how do you get your PS feedstock? We have a number of suppliers at the moment. I don't want to give away our sources, but yes, we have a large retailer that we're working with. We're also working with a couple of the larger recycling companies. You'll know them if I sort of say the names, but obviously sort of for commercial reasons I can't really sort of divulge names. Okay, I think that's it from a demonstration. Do we have any more questions? There's a hand up there if you want to sort of download it. And once again, I think Alex, who's been moderating calls, is going to share the video afterwards with everybody. Any more questions? Well, I think that's all the questions as we go along. I'd like to sort of say thanks to Alex for moderating, and thanks to Paul for doing his demo. And once again, if you've got any questions, once again, just feel free to speak to us. Hold on, we've got another few questions on here. Phil, do we need a concrete base? No, you don't, Phil. It works probably better on a concrete base, but we can sit them on what's called ground screws. If you want to sort of Google ground screws, you'll sort of see how they work, how the building sits on them. Jonathan, can I sort of put plumbing in the cavity? Yes, you can. In the same way you can electrics, no problem at all. Once again, it's nice. The void is wide enough to sort of fit all standard plumbing. Alicia, yes, can I click the shell? Yes, the idea. Yeah, of course you can. Hang on, here we go. Andrew asks, what breed is Alfie? I've got to know. Yeah, what breed is Alfie? I've got to know this now. Welsh Terrier cross. Well, I must admit, all terriers look a bit cross, don't they? But yeah, lovely looking dog. We actually have a Maltese at home, which is a Maltese Terrier and a Shih Tzu. And yeah. The less said about that, the better. Okay. Amanda has an idea. There we go. Any more questions before we call that a wrap for the day? I think that's it. I think that's all the questions we have. Well, thanks for attending. Hopefully it's been informative. Once again, if you have any more questions around the crowdfund or even just general queries that you think of later, you can get me on my email, which is gary.giles@ogelworld.com. I'm not sure if Alex has a slide for that. I don't know if he has. Don't worry if he hasn't. You can sort of, the details will be in the handout that's sent out to you. Okay.